Example number 3 for us here is very similar to our last, where we're trying to order different things. For example here, in how many ways can the first, second, and third batters on a baseball team be selected if there are 10 players on the team? Well, let's try to think this through with the fundamental counting principle. First of all, this problem is different from the last ones that we did, because when we were arranging our CDs on the shelf, we wanted all 9 of our CDs to be there. In this case, we have 10 players. We only want to select 3 of those players to be our first, second, and third batters. We don't really care about the rest of the order. So if we have 10 players on our baseball team, there are 10 possibilities for who is going to bat first. And then there's only 9 players that are left. So 9 possibilities for who can bat second. And then there's only 8 batters left, only 8 players left to see who could bat third. So 10 times 9 times 8, this covers my first hitter, my second hitter, my third hitter, and the rest of the players, I don't know, maybe they don't matter. Maybe we only, I don't know, maybe we want our best chance to win. So we only, I don't know, care about the first 3 outs. But type this in 10 times 9 times 8. We have 10 players on the team and we're selecting 3 of them. There are 720 ways that those first, second, and third hitters can be selected. This actually leads us to a formula for permutations. Okay, our formula has capital P, and then we have a subscript N and a subscript R on either side. And our formula equals N factorial over N minus R factorial. Okay, what on earth does this mean? So that capital P stands for permutations. N is the number of items that we have. I'm just going to say the number of items in a set. R is how many we are choosing to be arranged. Okay. So if we look back at this example here and kind of see how our formula would work in this case, I have 10 baseball players on the team. So that's my N. That's the number of items we have in our set. So if I again was trying to figure out how many different ways these first 3 batters can be selected on our baseball team, I have 10 factorial on top over N minus R. Well, we figured out N was 10 already. Minus R is how many are being arranged. We have 3 batters. We have first, second, and third batters that we care about. So R is 3 in this case. 10 minus 3 factorial. Okay, so we could type this in our calculator too. Just like this. If we do 10 factorial divided by 10 minus 3 factorial, we get 720 again. Not really the reason this works. It works the same way as before, the same way as what we did up here. That 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 10 minus 3 is 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. These guys really all cancel out. And look at what we're left with, the 10 times 9 times 8. So just another way to get there. This permutations formula will be a little more helpful as we go through and keep practicing permutations here. So just going to outline this here. And that's the end of this example.